Hi, everybody. Thank you for joining us in this webinar series. First of all, I hope you can be able to see my screen. Can maybe just give me a thumbs up.
Yes,
All
we
good.
can see it.
Fantastic. Thank you again. So in today's session, we'll take a look at inspecting traffic to private endpoints with Azure Firewall. My name is Andrew Mathu, and my co-presenter will be Gustavo Modena. Just a bit about the presenters to put the faces to the names. My name is Andrew. I'm based in Nairobi, Kenya, and I'm a member of the Azure Network Security CGTP team. I have a background in cybersecurity, networking, and network security. My co-presenter is Gustavo Modena. He's been with Microsoft and has experience with Azure Network and network security since 2016. And prior to that, he was dealing with networking and infrastructure from 2004. Gustavo is based in Charlotte, North Carolina. For our agenda today, we'll take a look at Azure Firewall. We'll go through an overview of Azure Firewall. We'll take also a look at the feature comparison for the various firewall SKUs. We'll also take a look at network versus application rules, as these form a foundation of what we're also going to discuss. And then we'll also take a look at why we are using Azure Firewall to inspect private endpoint traffic. We'll also take a look at Azure Private Endpoint. We'll have a high-level overview of what is private link, private endpoint, the various deployment scenarios when we use Azure Firewall, and we'll also take a look at some key routing concepts that enable these architectures to work. Finally, in the second part of the webinar, we are going to have a demonstration so you can be able to see how you can be able to set up this architecture and increase security to your private endpoints. So to kick us off is an overview of Azure Firewall. And this is a managed cloud-based network security service that protects our Azure virtual network resources. So with Azure Firewall, you get key benefits which are within the Azure Firewall features. You'll have networking and application traffic filtering. So with this, you're able to filter incoming and outgoing traffic. So it will allow you to create and enforce rules for traffic filtering based on various criteria, such as source and destination IPs, IP addresses, ports, and protocols. It also supports with the application rules, the filtering of specific applications and services, such as Azure PaaS services, and also HTTPS and SQL. Azure Firewall also has built-in threat intelligence. So with this, you're able to filter bad domains, bad IP addresses, and of course, they're dropped before they enter into your environment. Azure Firewall, like I mentioned, is cloud-based, is a cloud-based native solution. So it's able to deploy and scale in minutes. And it also supports east-west and north-south traffic filtering. Currently, we have 3 supported SKUs. This is the basic SKU, standard SKU, and the premium SKU. So in terms of comparisons between these 3 SKUs, starting with basic, for Azure Firewall Basic, this is our entry-level firewall intended for SMBs, small, medium enterprises. So with this, it supports customers with throughput needs of less than 250 Mbps. Azure Firewall Basic includes layer 3 to layer 7 filtering and also alerting on malicious traffic with a built-in threat intelligence from Microsoft Threat Intelligence. It is easy to set up. The setup can be done in a few minutes. It supports automated deployment, so you can deploy it as a code. It has 0 maintenance as it's supported with automatic updates, and it can also be centrally managed via the Azure Firewall Manager. For Azure Firewall Standard, this is mostly recommended for customers looking for layer 3 to layer 7 firewalling needs. It supports auto-scaling to handle peak traffic. up to 30 Gbps. It also supports enterprise features such as threat intelligence, DNS proxy, custom DNS, and web categories, as you can see in this table. Finally, we have Azure Firewall Premium, and this is recommended for securing highly sensitive applications such as an example payment processing. It supports advanced threat protection capabilities with IDPS and TLS inspection. So with this, you get all the features that are in basic and also in standard. So within the Azure Firewall, we have various types of rules that control the entry and exit of traffic. We have the networking rules, and these rules are created to control traffic for any protocol by using FQDNs or IP addresses. So the networking rules, you're able to allow or deny inbound, outbound, and east-to-west traffic based on the networking layer, that's layer 3, and also at the transport layer, layer 4. Something to note is that networking rules are within what we call rule collections, and these have a higher priority than the application rules. And all these rules are terminating. So if a match is found in a network rule, no other rules are processed. Also, when using networking rules, when we integrate our Azure Firewall with a private endpoint, SNAT must be configured for the traffic destined to those private endpoints to allow for proper flow of that traffic. Now, application rules, these are used to allow or deny outbound and east-west traffic based on the application layer, that's at layer 7. And with this, you can allow HTTPS or Azure SQL traffic at that particular layer using FQDN and FQDN tags. So here's an example. You can see Windows Update. The use of application rules is recommended when inspecting traffic destined to private endpoints. And this is to allow and to maintain flow symmetry. So when you're using application rules and integrating the private endpoints, SNAT is automatically performed. And this is the opposite of the network rules where you actually have to configure that SNAT. So in this section, we'll take a look at why we're inspecting the traffic to private endpoints with Azure Firewall. So the importance of this integration is that it provides an additional layer of security for the traffic to and from the Azure PaaS services. And of course, with this, you also are able to reduce the attack surface. So all of this, since traffic to the private endpoint is within the Microsoft backbone, you also eliminate the need for a public endpoint. So that, of course, also helps in the overall reduction of the attack surface. So with Azure Firewall, the additional protection you get to your private endpoint is with on the data protection. So you're able to protect your sensitive data. You're also able to maintain compliance if you're in a sensitive industry and there are compliance and regulatory compliance standards that you need to follow, such as GDPR, PCI, if in the banking sector. So with the addition of Azure Firewall, you're able to maintain that strong compliance stance. You also have the inspection capability of Azure Firewall. So with the addition of the network rules, application rules, IDPS, you're able to stop threats. And we know that these threats can also occur within the Azure environment and traverse through the private endpoint link. So it's important to have this additional layer, and this inspection capability will definitely add value and to be able to stop any advanced threats. And also, of course, with Azure Firewall, you have the ability to log the firewall logs, and these are available for your security management, for your auditing. So it gives you visibility into that traffic that is traversing through the private endpoint. And so with this, like I mentioned, you have that defense in depth. You have another layer of security for traffic that is destined towards your private endpoints. And this now forms the basis for this webinar, and we'll also take a look in the next section at how you're able to do this integration. Great. So in this next part, we'll take a look at a very high level. What is private link, private endpoint, and the various deployment scenarios that we use to integrate with Azure Firewall. So to begin us off, private link, this is a secure and scalable service that provides private connectivity from a virtual network to an Azure PaaS service, customer-owned or Microsoft partner service. And in this case, PaaS services example can be Azure Storage and your SQL database. So traffic between the virtual network and the service travels through the Microsoft backbone. So you don't expose this service to the public internet. So at no point is your service exposed through a public IP address, as everything is within Azure. And then these services are delivered directly to your customers' virtual networks from the private link service in your VNet. So this, you can have a customer service provider setup, whereby when you publish this service, your customer is able to access it securely and privately. In terms of a private endpoint, this is the network interface that has an IP address from within your virtual network. So the private endpoint allows you to configure private IP address endpoint for your PaaS applications, and it allows your internal resources and customers to connect to it either over VPN or over peered networks. So this network interface will allow you to connect privately and securely to that service, and that service is now powered by Azure Private Link. In terms of the services that you can access, you have the Azure Storage, SQL database, and MySQL. This is just an example of some of those services. You can also take a deeper look into private endpoint and private link. We've shared this in this particular deck. And once the webinar is over, you can be able to go over it and get more details on the two services. Now, when it comes to Azure Firewall inspection of traffic going to the private endpoint, we currently have 4 supported scenarios. So this is whereby you want to inspect that traffic with Azure Firewall. Like we saw the benefits that accrue from it, the visibility, the stopping of the advanced threats. The first scenario that is supported is what we call the hub and spoke architecture. And this is where you have a dedicated virtual network for your private endpoints. So in this first deployment scenario, this is the most expandable architecture to connect privately to multiple Azure services using private endpoints. So you'll have a route pointing to the network address space where the private endpoints are deployed. And then the advantage of this configuration is that it reduces administrative overhead, and it also prevents running into the limit of 400 routes. So with this, you're able to deploy quite a large number of private endpoints and be able to access them from your virtual machine. The second deployment scenario is also a hub and spoke architecture, but in this scenario, you have a shared virtual network for the private endpoints and virtual machines. So the virtual machines and the private endpoints are in the same VNet, and you can deployment in separate subnets within that VNet. And for the purposes of our demo, and also this is in our blog space, this is the scenario that we are going to take a look at, but also good to understand the other scenarios that are listed. We also have a single virtual network, and this is used when a migration to a hub and spoke architecture isn't possible. So you have the Azure Firewall, your virtual machine, and the private endpoint in the same virtual network. And then finally, the last scenario is on-premises traffic to private endpoints. So this architecture can be implemented if you have configured connectivity with your on-premises network, either using ExpressRoute or a site-to-site VPN. and you want to access that private endpoint within Azure. So like I mentioned in this webinar, we'll take a look at this second deployment architecture. And this is the hub and spoke architecture, where you have a shared VNet for the private endpoint and the virtual machine. You can see here how this architecture looks like. You have a hub virtual network where you have your Azure Firewall, where it has been deployed, and you have the spoke virtual network with your virtual machine and the private endpoint. So in this case, this scenario is implemented when it's not possible to have a dedicated virtual network for the private endpoints. So if you are not able to deploy scenario number 1, you can use the second scenario. And this is also deployed when you have a few services that are exposed to the virtual network using the private endpoint. So something to note about this architecture is that the virtual machines will have /32 system routes that are pointing to each private endpoint. So you have one route per private endpoint, which is configured to route traffic through the Azure Firewall. The second point to note is that there's also an administrative overhead of maintaining the route table, especially as the services increase, as the private endpoint services are increased. So there's a possibility of hitting the 400 route limit. So that's why we mentioned it's always recommended to use scenario 1 to avoid hitting that particular limit. In terms of routing, what is there to note is that user-defined routes do not affect traffic coming from private endpoints. So traffic coming from the private endpoints is going to be bypassed. The second thing is that, like I mentioned, the private endpoints will automatically get a /32 default route for each private endpoint that will be propagated to each VNet or peered VNets. So for example, if you have traffic traffic from a hub to a spoke to where the private endpoint resides, you might have an issue, especially whereby you want to ensure that that traffic is routed through your firewall or network virtual appliance. So in this case, you can configure a user-defined route, and this can be used to override traffic destined for that particular private endpoint. And then just to note here again, to emphasize, is that the virtual machines will have a /32 system route pointing to each private endpoint. So you have one route per private endpoint, and this is configured to route traffic through the Azure Firewall. Great. So with that introduction, with that background, the next section is the demo section. And this is where my colleague Gustavo is going to take us through the setup of this particular architecture. And that is for the second deployment scenario using the hub and spoke, where you have a private endpoint shared with the virtual machine. So Gustavo, over to you.
Thank you, Andrew. Hello, everyone. So from now on, we're going to go through the demo. I would like to start by showing you, our blog that we posted last week, where you're going to be able to find exactly the same scenario that we are going to discuss here right now, right? So the scenario is, as Andrew said, is the hub and spoke architecture, where we are using the same VNet shared between the VMs and the private endpoints, right? In this blog here, you will see what are the resources deployed for this lab scenario here. And you can even use the Terraform template that we make available here. These Terraform templates are available in our GitHub repo under Azure Firewall. And then you will find a folder called template inspecting traffic to PE with Azure Firewall. Under this folder, you're gonna see 3 different Terraform templates, one for each scenario. So one for dedicated private endpoint VNet, one for hub and spoke with shared VNet, and one for single VNet. To deploy this Terraform template, you're gonna need to let me go back to the blog. You're gonna need to make sure that you have your computer ready for running Terraform template. So you can follow this link here to prepare your computer to run Terraform templates. And once you have it all prepared, you're gonna be able to run the template to deploy the environment. So here we have all three templates. I'm not going through every one of those. I will focus on the hub and spoke one. And then here we can see that we are not only creating all the resources, but applying all the required configurations to have the traffic going, from the VM to the private endpoint through the Azure Firewall. So here we are pretty much creating, the resource group. In this case here, we are creating the MySQL PaaS service. You could create a storage account, Azure SQL, or any other PaaS service which supports private endpoint for this purpose. In this case, we are using MySQL because we wanted to show the SNAT configuration on the Azure Firewall since MySQL is not supported in the application rules. Then here we are creating the private endpoints, public IP that will be used by the Azure Firewall. Then here we also have the firewall policy. Just a quick information, the policy that we are creating here is a premium policy because the firewall we are creating is also a premium firewall. If when you are going through before you deploy this template, if you want to change this queue to standard or basic, you can do it by changing the template. It's not complicated to do it. And within the policy, we are creating the network rules, the rule collection groups, the application rules that we're going to use. I will show you the rules that we have created in the portal. I think it's more friendly to see. Then what else we have here? We have the route tables to meet the requirement of sending the forcing the traffic from the VM to the private endpoint to go through the Azure Firewall. So we have it here as well. Then the hub and the spoke VNets that we have. Remember that the spoke VNet has a subnet that we are pretty much sharing the VNet between the VM and the private endpoint. Then we have the route table association, the Azure Firewall Premium itself, the VM that we're going to use to test this environment. And what else? Here we're going to see the username and the password. We highly recommend you to change this username and password when you are going to deploy it for test purpose. Just to have your own password, not be using a password that's declared here. Then for this lab, we need a DNS. We are using the private DNS zone. If you have a custom DNS in your environment, it could be a Windows machine or a Linux machine. You could use it. You don't need to create the private DNS zone. And then we have the firewall settings here as well, right? So in order to deploy it, you're going to run the Terraform process to, creating, you're going to run the Terraform init. You're going to run the Terraform plan to go through the config file and then see what resources need to be created. And finally, you're going to run the Terraform apply. I'm not going to deploy it right now because this deployment takes between 5 and 7 minutes. But I just wanted to go through the Terraform to let you know what resources are being created here. So next, let's move to the portal. So this is the resource group that the Terraform template has created, right? And then under this resource group, we have all the resources that I just mentioned, right? a few things that are important to go through just to make sure that the environment, what you need to have for these configuration to work, right? So beginning from the VNet configuration. So we have two VNets. One is a hub VNet and the other one is a spoke VNet. We need to have some kind of connection between the VNets because by default there is no communication between different VNets, right? Here we are using VNet peering, so we need to have the VNet peering configured on both sides. You could be using a VPN connection or something else. Just for the purpose of this lab, we are using VNet peering. Second, and the important thing is that the VNet peering needs to be done on both VNets, right? So this is showing the configuration applied to the hub VNet. That configuration also needs to be applied on the spoke VNet. Then we have our, private endpoint here that was created. A few things that are important to mention when you create the private endpoint and it needs to be having a PaaS service, right? In the process of creating the private endpoint, you need to have approval to connect the network interface to the PaaS service. That process is usually automatically, but there are some scenarios that the approval is not approved automatically, and you need to go through a specific process to approve it. You're going to see the connection status here is approved, and how it was approved. It was auto-approved. If you don't have this connection status showing approved, it means that the connection, the private connection through the private IP address will not work. One other thing that it's important to highlight here is the DNS configuration. So when we create a private endpoint, the NIC with the IP address from your VNet will be, we will receive an IP address from your VNet. It's going to be auto-assigned, and you see the FQDN that is expected to use when you are sending a request to the private endpoint. And here we can see what's the IP address that from your VNet that's being used here. If you are using a custom DNS, as I said, a Windows VM or a Linux VM, and you have your DNS managed by your team, then you just need to make sure that you have a zone configured in your DNS environment to, in this case, to mysql.database.azure.com. If you're using a storage account or other PaaS services, this zone will change accordingly to the private endpoint that you are creating, right? As I said, in this webinar, we are using the private DNS zone. So here we will see the A record for the private endpoint. And one thing, if you will use the private DNS zone, is that you need to create a virtual network link, which allows the virtual networks to send DNS queries to this private DNS zone. If you don't have this link, this VNet link created here or completed, the VMs under that VNet won't be able to send DNS queries to this private DNS zone. So that's another important step to confirm. If you deploy the environment using the Terraform template, you don't need to do anything, any of these configurations, because it's all configured by the template. Then here we'll see, the network interface that's being used by the private endpoint. This network interface here is the same one that we saw in the private link. So we can see here under the DNS. Oh, sorry, not this one. Oh, yeah, this one. That's right. It's auto-approved. We're going to see the name of the network interface here. Then we have our Azure policy. Let me go through the Azure policy just to show you what we have here. So let's start with the network rules. We do have a network rule allowing traffic from our VNet 10.10.11.0/24 to 10.10.11.68/32 on port 443 and 3306. And we also have an application rule allowing traffic to the FQDN of the private endpoint. Why we are showing you these two rules, right? It's important to mention that the application rules only supports traffic, HTTP, HTTPS, and Azure SQL traffic. If you have a service that doesn't use these three protocols, for example, the MySQL doesn't use it, then you're gonna need to have the rule allowing traffic to the port, in this case 3306, which is the port used by the MySQL to allow traffic to go through the firewall. And the other thing that is really important and makes all the magic here is the private IP ranges. As Andrew was saying, if we are using network rules, we need to configure these net to make sure of the to guarantee the flow symmetry, when traffic is going between the VM and the private endpoint. If we don't configure the SNet here, what's going to happen is that the VM will send the traffic to the private endpoint through the firewall, but on the way back, since we are not able to apply a UDR on, the UDRs are bypassed by the private endpoints, the private endpoint will try to send the traffic directly to the VM and not to the firewall, back to the firewall. So that's why it's important to have the SNet configured, because that way, when the private endpoint receives the traffic coming from the firewall, it will see the source IP address as one of the firewall instances, and then the return traffic will be sent to the same instance, and then the firewall will send that to the VM. So here we are saying that we want to SNet traffic to everywhere except these two networks that we have here. One of these is the hub VNet, and the other one is the subnet that I have for my VMs. So other than these two networks here, all the traffic is getting SNetted. There are some different ways. If for example, if you just want to, SNet everything except traffic to RFC 1918 ranges, then you can define a subnet for the private endpoints that doesn't use, any IP ranges from the RFC 1918. So that's another way to configure this environment if you want. In this demo, we are not doing any demonstration of TLS inspection or IDPS, but it's important to mention that if you want to enable IDPS signatures for to inspect the traffic from the between the VM and the private endpoint, you can enable the IDPS as well, and then select the signatures. One important thing to mention here is that the signatures have the directions, right? So you see signatures that are intended to inbound traffic, other that are intended for outbound traffic, or any, or even internal traffic. So in this case, for to inspect to apply the signatures when inspecting traffic between the VMs and the private endpoint, then you need to focus on the signatures that have any on the direction or internal on the direction. That's it for the firewall policy. So let's go back to the resource group. But yeah, one other thing before we test and show that the traffic is really going through the Azure Firewall, right? So in our Azure Firewall, just to let you all know, we have a diagnostic settings. And then in these diagnostic settings, this first one will be the one that the template will create. The second one is one other test that I was doing. But yeah, when you deploy Terraform, you see one diagnostic setting already configured on your Azure Firewall, and selecting only two tables for the sake of this demo only. If you want to apply this in production, then you may want to select more categories here to to have access to the logs generated by Azure Firewall. And finally, we are going to test these environments. So just to remember, what we have here is our VM, right? And I'm going to connect to the VM via RDP. This VM is a Windows VM. And the idea is to test the connection to the private endpoint by using the public name, right? The public FQDN. So in the VM, we're gonna, let me copy the FQDN that we need here. So I go to the private endpoint, and then under DNS configuration, I'll see what's the FQDN that I need to use. I go back to my VM, I open the PowerShell, and to test this connection, we're gonna run a command called test net connection minus computer name. Then we're gonna paste the FQDN here, minus port, and specify the port used by the MySQL. So the port here is 3306. When we run it, we're gonna see the results. So what we have here in the results is the computer name, that the remote computer name that we are connecting to, which is the FQDN of the private endpoint. Then the remote address. So this is the IP address of the private endpoint, the one from our VNet. Then the remote port 3306, as we specified here in the command. And then the source IP address. This 10.10.11.40 is the IP address of my VM, and the TCP test succeeded. It would show true or false depending on the results. So in this case, our test is successful. So you're connecting to the private endpoint. In order to have the logs available, I just want to run a few more connections. That way, we're going to see multiple logs in our workspace. And also to confirm that the traffic's going to the firewall, we can run a tracer RT to the FQDN. And then we're going to see that the first hop is the IP address of one of the instances of the Azure Firewall, right? So 10.10.10.7. I know this is the this is part of the Azure Firewall subnet, so I know this IP address is coming from one of the firewall instances. So that way, I can confirm that the routing from my VM to the private endpoint is going through the firewall. Before we look at the logs, I want to show the effective routes, right? So to have access to the effective routes, we're going to look for the virtual machine, and then networking, click on the network interface. And then on the left side, if we scroll down, we're going to see the effective routes. When we create a private endpoint within our VNet, we're going to have a route automatically added by the system route in the route table for the VMs on that VNet, right? So when you do the effective routes, you see a default one. When on the source column you see default one, it means that this route is being learned by the network platform on Azure, right? And the reason why it's showing invalid here is because I have another route which is coming from my route table with the same prefix, so 10.10.11.68/32. And the difference here is that my route table, my user-defined route, is sending the traffic to a next hop, which is my Azure Firewall, so 10.10.10.4. And if we look at this last line here showing invalid, we're going to see that the next hop would be the interface endpoint. So as we are applying a route table to the VM subnet, this system route is being overwritten by the route that I have in our route table. So that's another way to confirm. If you create a route table, a static route with a higher, a bigger range here. So instead of using the /32, you will not override the system route because the system route is more specific. So every time we create it, it's going to add a /32. So in order to override this, you need to create a route in a route table with a /32 as well. That's the only way you'll be able to override the routing. One last thing before we move to the logs, it's the route table itself. So the route table here, we're going to see two routes. So I have one route sending the default traffic 0.0.0/0 to the virtual appliance IP address. In this case, is my Azure Firewall. And then a second static route sending the traffic to the private endpoint to the firewall as well, right? And here we can also see that this route table is applied to the app subnet, which is the subnet where I have my Windows VM that I used for testing allocated. All right, then let's go to our Azure Firewall here and look for the logs. So in the Azure Firewall, we can scroll down to logs, click on logs here, and the query that I want to do is this query here. So this query is, this lab is already using the new resources specific logs. So when we run the custom query, we need to specify the table, right? So as I know that we are using the network rules, I'm going to run the query against the AZFW network rule table, right? And then I want to look for the destination IP contains 10.10.11.68, which is the IP address of the private endpoint, and the destination port is 3306. And let's do it over the last hour. So this is another way to confirm that all the traffic, from the VM to the private endpoint is going through the firewall. We can see here the source IP is the IP address of the VM. What's the source port? So this is, the different connections that I tried when running the testnet connection. The destination IP is the IP address of the private endpoint. The destination port is the port used by the MySQL. All the actions are allowed because it's hitting my network rule called network rule collection to rule 1. It's under this network rule collection here, and that's the way how we can prove that the traffic between the VM and the private endpoint is getting inspected by Azure Firewall. So two ways to confirm that is running the trace route command from the VM. You're going to see the next hop is an IP address of one of the firewall instances. And the second way is to looking for the logs and make sure that you have the logs allowing the traffic to go to the private endpoint. That's pretty much it for the demonstration. I hope you all enjoy it, and I wanted to open the floor for questions.
Great. Yeah. Thanks, Gustavo. We do have a few. First one is, what about protecting Azure private link services that we create or host?
What do you mean by creating private endpoints that you create or host? Can you elaborate a little bit more on that?
While we wait for the person who asked the question to elaborate, I can just jump to the next one.
Okay.
If the endpoints are private in nature, is there really a concern for attack?
Yeah, you may have, that's a good question. Thanks for asking it. The threats are not only coming from out of your network, right? There are situations where you have lateral attacks, so coming from your internal networks, and that's why it's important. And we recommend to inspect the traffic and use, Azure Firewall in this case to inspect the traffic and allow the traffic coming from very specific networks. It doesn't mean that the traffic coming from your network is secure. It could be, let's say a workstation that has been attacked and it's being used as a bridge to connect to your internal services. That's why we recommend using, inspecting the traffic to your private endpoints. Let's say, for example, in this scenario that we just demonstrated here, we have a private endpoint for the MySQL. So in this MySQL, we may have a lot of sensitive information that we don't want to expose to, everybody on our internal network. So you might need to you may need to specify exactly what are the networks that you want to grant access to to the private endpoint, and then use the Azure Firewall to protect it.
Great, thank you. The next question we have is, can you run a packet capture on the firewall interface?
That's good point. Thanks. It's not available today yet. It's part of our roadmap. We do have plans for future to allow packet capture, but it's not available today. If you need something like that, the recommended is to reach out to the support team to open a support ticket, and then the internal teams have access to run a packet capture and provide information about it.
Great, thank you. The next one we have is how to use a private endpoint for database that uses Power Apps user interface.
I'm not clear on that question. Can you repeat it, please?
Yeah. How do you use a private endpoint for database that uses Power Apps user interface?
I'm not sure about that. That's more on the Power App side. Sorry, but I don't have enough information to respond this one.
No problem. The next one we have is, does Azure Firewall need public IP address for any kind of management aspects?
For Azure Firewall, when you deploy the Azure Firewall, you do have the option to not assign a public IP to the transit interface, right? For managed purposes, you always need to have a public IP address. And that's why, when I say managed purpose, is for Microsoft managed purpose, because Microsoft needs to apply the updates on the firewall instances as we release new versions of the firewall, right? And the only way to, for Microsoft to apply these updates is by using the public IP addresses. If you don't want to have a public IP address assigned to your firewall, you can enable the forced tunneling. And when you enable the forced tunneling, you have a second interface, which is used for management only. So this it means that the interface used for transit will not have any public IP address assigned to it. So you won't be able to do DNAT traffic or outbound traffic using the IP addresses assigned to it. But you still have a public IP address assigned to the management interface that cannot be used for for inbound or outbound traffic. It will only be used for Microsoft update purposes.
Great, thank you. The next one we have is, can we route the traffic on the VNet gateway through the firewall of the VNet? If yes, how?
Can you repeat the question, please?
Yeah. Can we route the traffic on the VNet gateway through the firewall of the VNet? If yes, how?
Oh yeah, that's you can apply a route table to the gateway subnet when you have a VNet gateway deployed, and on that on that route table you assign to the gateway subnet, you will add the static routes sending to the next hop, and then in that case the next hop would be the Azure Firewall.
Great, thanks. The next one we have is, can we forward collected IP flow observed on Azure Firewall to other external packet analyzer?
Like, can you elaborate on that? Is that like taking packet capture from the Azure Firewall and then opening the capture in a software like Wireshark or something like that?
Well, we'll wait for them to elaborate, but I'll move on to the next question.
Thanks.
Is the traffic traversing the private link encrypted, especially on the shared virtual network for private endpoints architecture?
the traffic between, the when you have traffic coming to the private endpoint, right? There's a link between the network interface and the PaaS service. So that communication is encrypted. And let's say, for example, it also depends on the service that you, the PaaS service. So for example, for storage accounts, when you have a private endpoint for blobs, then that communication will be using HTTPS traffic, so it's all encrypted. It depends. It also depends on the PaaS service that that's behind the private endpoint. But yeah, it is encrypted.
Great. Well, I think that's all the questions that we have. So I'd like to thank you, Andrew and Gustavo, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/security-community. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/Azure NetSec feedback. Thank you and see you next time. Goodbye.